Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2021, problem number 58. The problem says that the number of real roots of the polynomial fx is equals to x to the 11 minus 13x plus 5 is. So basically we have to find the number of real roots of this polynomial of degree 11. So obviously we can't solve this equation, right? We can't solve it. So how are you going to approach this problem? So let's use calculus. So fx is this x to the 11 minus 13x plus 5. So f prime x, that means the first derivative, is 11 into x to the 10 minus 13. So now this entire thing, this f prime x, that means the derivative, is positive if x to the 10 is greater than 13 by 11, right? And negative if x to the 10 is less than 13 by 11, this quantity. If x to the is x to the 10, x to the power 10 is greater than this quantity 13 by 11, then it's positive, otherwise it's negative. And 0 obviously if it's 0. So see, we can actually, now obviously we x to the 10 we can't solve this, right? So what we're going to do is, see, we can obviously have a general idea of how the graph of x to the 10 looks, right? It basically looks like the graph of x square, but obviously it's going to be much steeper beyond 1 and minus before minus 1, and a lot more, you know, curvy in between the minus 1 and 1, right? So basically it looks like this. It basically looks like this entire quantity looks like this, right? This is the graph of x to the 10. Now this 13 by 11 is some number in the y-axis, some positive number, right? It's greater than 1 but less than 2 obviously. So it's going to be this. So this line, if this line cuts this curve at 2 points, say that it's alpha at minus alpha. So x to the 10 is greater than 13 by 11, right? Greater than these areas if x is either greater than alpha or less than minus alpha, right? That means if mod x is greater than alpha, you can see that. That means x to the 10 is greater than this quantity if and only if x to the mod x is greater than alpha and x to the 10 is less than 13 by alpha, 13 by 11, sorry, x to the 10 is less than 13 by 11, even only if mod x is less than alpha, right? Because if x lies between in this alpha and minus alpha, then obviously the value of x to the 10 is going to be less than this line, right? The curve lies below this line. So if mod x is between this minus alpha and alpha, then obviously it's going to be less than that. So basically what we, now obviously alpha is what, it is nothing but 13 by 11 whole to the power 1 by 10, right? If we solve this, but obviously we can't solve it without the help of calculator and all that. So alpha is actually this. So this quantity is quite crude to see, deal with. So basically that's why we are using alpha here, right? We are using alpha. So you can see that therefore it's nothing but this boils down to f prime x, the derivative is positive if mod x is greater than alpha and negative if mod x is less than alpha, right? Just using this thing, replacing this thing and this mod x less than alpha in place of this thing, right? So now clearly we can see that f has a local minima at x is equals to alpha. Why? Because it is positive. See, here it's the, suppose the line, the real line, it's minus alpha and plus alpha. So f prime is positive if we are talking about beyond alpha or before minus alpha, right? So here is positive, and in between alpha and minus alpha it's negative. So you can see the curve is something like this. It's increasing, achieving a local maximum at minus alpha, then decreasing, achieving a local minimum at alpha, and again increasing, right? It's the curve is actually of this form, something like that. But we don't know the value of the function at that local minimum. If it is something, say if it is something which is positive, suppose the at this point is positive, that means the curve is obviously something like this, right? It is not actually cutting the x-axis more than 1 point. It is cutting before minus alpha obviously at some point, because it is increasing before minus alpha. It was increasing, and it is increasing from the below, because it is a monic polynomial, right? So the polynomial is monic, this thing. The to the 11 is actually 1, it's positive, so it is actually increasing from below. From here the curve starts from minus infinity. So before minus alpha it is cutting at some point, then it is increasing, and then it is decreasing at alpha, and achieving its local minimum at alpha, and then decreasing, but and then obviously again increasing. So if this minimum value, this local minimum, if it is something positive, say if it, then after cutting it at this point, at this point, this now one of the numbers before minus alpha, at this there is obviously a root. Say, suppose this is r1, suppose this number is r1, suppose. Here I have written that there exists exactly one real number r, such that r is less than minus alpha. Here it should be minus alpha, less than minus alpha, such that f of r is 0. Here is going to be exactly one real number where it cuts, because obviously before minus alpha it was increasing. See, this problem is actually very intuitive to deal with. There is not much to write about this problem. It's very intuitive. So before just before minus alpha, it was strictly increasing, right? It is something like this. So exactly one, there was exactly one real at one point at which it was cutting the x-axis, right? There was exactly one real number r before minus alpha, such that f of r is 0. So there is obviously one root. We have already got one root, right? Now then it is achieving a local maximum at alpha, at minus alpha, a local maximum. We don't care about that value, but it is achieving a local maximum. Then again it is decreasing. Now as it is decreasing, is it actually cutting the x-axis and going something like this, or is it actually not cutting the x-axis? There can be two scenarios. It is decreasing and the minimum value achieved at alpha is something positive, and then again increasing. In that case, the only real number was going to be this r thing, right? This r thing, something like this. But there could be another case, something like it is increasing, and then it is again decreasing, and then it is again increasing, right? It could also be the case like that. So in that case, something like this. So it is increasing and then again decreasing, say achieving it local minimum at alpha, and then again increasing. In that case, it would have been a real number in between minus alpha and alpha is a root, and again a real number beyond alpha a root. Therefore there would be three roots in total. So see, just to take a few values, f of 0, what is f of 0? F of 0 is, you can put it here, f of 0 is actually 5. F of 0 is 5. So f of 0 at this point here it is 5. Now f of 1 is minus 7. If of 1 is minus 7, it is going to be something like this. And if of minus 1 is 17, right? So you see, we don't know the value of alpha. I mean, it's obviously difficult to calculate using hand, but we do know it's going to be something greater than 1, right? It is something greater than 1. Alpha is something greater than 1. So here it is alpha, suppose. Then it is obviously the function is decreasing. At alpha, it is actually negative, right? So at alpha it is negative, and at minus alpha it was going to be some positive quantity, some the local maximum. So the function is something like this, increasing, achieving the local maximum at minus alpha, then again decreasing, something like this, and achieving the local minimum at alpha, and then again increasing. Therefore the function is having it's actually cutting the x-axis between minus alpha and alpha, and again cutting it after alpha. So there are actually three roots. Therefore there exist real numbers r1, r2, r3, where r1 is less than minus alpha, r2 lies between alpha and minus alpha, and r3 is greater than alpha, such that all of them yield the number 0 when put into the function. Are you getting my point? See, alpha is obviously going to be, we don't know the value of alpha, but we can somehow say that it is greater than 1, right? Because 13 by 11 is greater than 1, and we are taking the 10th power of it, the 1/10th power of it. So it's also going to be greater than 1. It has to be, right? So at f of 1 we are finding it to be minus 7, it's negative. At f of alpha it's also going to be negative, right? Because it is even lower than that, because we already know that the function achieves its local minimum at alpha. So it's obviously going to be even less than minus 7, something like this, something like here. And after that it's going to be increasing, something like this. So obviously the function is something like this increasing, decreasing, and then again increasing. So there are three values. So there are three real roots of this polynomial. That's it. Do like, share, and subscribe to the channel for more exciting problems. See you till next time.